Welcome to another informative video brought to you by Autruo. There are quite different methods for starting electrical motors, which include but not limited to direct online or DOL. Star delta, Autotransformer, primary resistor, and finally using a solid-state device, such as VFD or soft starter. All the methods listed above have their own applications and benefits. Looking to learn industrial processes and receive a notification when we release a new course, please click the like button, subscribe, and hit the bell notification. That way you won't miss our new release. Today, you will learn about drives. Specifically what they are and when do we use them with automation and PLCs. During starting, electric motors usually require a huge amount of current during startup, for example, when the inertia of the electric motor rotor is changed from rest, or the force that will change the state of the load on the shaft from rest position. This will require a huge amount of effort and energy, which in turn increases the starting currents that will be required to start the motor before it reaches its nominal speeds. An electric drive can be used to limit the inrush current of the electric motor, during which results in a smooth and gradual startup. Electrical drive prevents the motor from damage, and to some extent, it also increases the electric motor lifespan. This method usually prevents the motor from heating up during start and stop operation. By reducing mechanical stress on the motor's shafts and the electrodynamic stress on the connecting cables. It also reduces the operational cost of the system, because of its less current consumptions. So what exactly is a VFD? It stands for variable frequency drives. They are used for running AC motors at varying frequencies in order to achieve a smooth startup. It works by adjusting the frequency of the drives, which in turn increases the speeds of the drives. The VFD has three main components: the rectifier, which is where the input is connected, the filter, and an inverter circuit. The rectifier are diode connected in a circuit form. The incoming AC voltage will be converted to DC voltage. The converted DC voltage will be further smoothened by the filter using capacitors. Finally, the inverter will convert the DC voltage back to AC voltage, which can be varied in hertz. The hertz will be used to drive the motor to specific speed known as RPM. A typical soft starter consists of 6 thyristors or SCR placed in a parallel configuration to start the motors. The main aim of this drive is to limit the inrush currents to the motors. What is a thyristor? A thyristor is an electric component that is made up of 3 parts: the logic gate, the anode, and the cathode. When internal pulse is applied to its gate, it allows current to flows from anode to cathode, which will be sent to an electric motor. When the pulses applied to the gate are interrupted, the current flowing to the cathode from the anode will be interrupted and the SCR will be in off states. The pulse is sent at ramp time. This way, the current is applied to the motor at a very reduced amount. This will allow the motor to start slowly. This reduces mechanical stress that might be generated as a result of sudden startup. When the motor reaches full speed, the soft starter will behave as other starting methods mentioned earlier. Now let's look at the major advantages when using electrical drives as compared to other starting methods. With the VFD or soft starter, the time the motor reaches full speed is slower and more controlled, but with the other starting method, the motor will reach its full speed almost instantly. By comparison, we can see that there is a high inrush voltage on the other starting method as compared to the VFD or soft starter method. The VFD or soft starter takes more time and the current is regulated, while in the other starting method, there come spikes and ripples, which is as a result of the mechanical part of the motor. This will tend to oppose the sudden change of the rotor inertia. This sudden charge has a significant effect. The torque applied to the motor using another method is greater as compared to the gradual starting of the motor using electric drives. So how do we know the type of starter to use for our applications? This should be determined by how much control your applications will require. If your application requires steady starting of your motors but not speed control, then soft starter is the best option. If speed control is required, then VFD is the best option. Now let's look at a typical real-world application of VFD and soft starter. In a plant setting where constant moving of item on a conveyor system, then soft starter is required. In a situation where the object is changing course and speed at interval, then VFD drive will be applicable for this process. In a similar scenario, when the process requires constant supplies of water for its operation, and the supply should not be varied in any way, then soft starter is the go-to device. Similar in a situation where the water supplied varied according to the level of the tank, then a VFD is the go-to devices. To cap it off, VFD in soft starter will ramp up and ramp down when starter and stopping electric motor, but the major difference between VFD and soft starter is the ability to control their speed at interval. VFD is used for speed control application while soft starter is only used for rapid starting of electric motor.